Hey there, Algebra 2 students. Today I want to talk to you about graphing the secant function and the cosecant function. And it's similar to graphing the tangent and cotangent, but different. Okay, so we always want to start with what we know about the secant function. We'll start with the secant. Remember that secant of x is the same as 1 over the cosine of x, right? And so I'm starting with the cosine function. I've drawn just the regular cosine function. And whenever the cosine is 0, that'll be problematic for the secant function, right? We can't have a 0 in the denominator. So the secant function will be defined every time the cosine function is 0 or crossing the x-axis. So the first thing I'm going to do is sketch in my asymptotes in the places, my vertical asymptotes, where the cosine function crosses the x-axis. So I don't know if you can see them. They're in green here. It's not a super dark green. But we start by graphing those asymptotes. Okay, so then let's work left to right. What happens, what's the reciprocal of the y value here, -1? The reciprocal of -1 is just -1. All right, 1 divided by -1 is -1. And so the secant function also goes through that point. Now, what will happen as we approach either asymptote? The cosine function is negative in this whole interval, and so the secant function will also be negative. As the cosine function gets closer to 0, the secant function will be approaching negative infinity. And so it will come like this. It's probably more U-shaped than that. So we'll just make it real dark, thick line. So it's going to go like that. All right. But we're going to continue here. Between -pi/2 and positive pi/2, the cosine function is positive, right? So the secant function will also be positive. And the reciprocal of 1 is 1. So the secant function goes through this point 0, 1 as well. So what happens as we approach the asymptotes? It's going to approach infinity on either side here, and it's going to look sort of like a U, right? Because 1 divided by a number very close to 0 approaches infinity. And this is a periodic function, and so we will repeat. It'll go through this -1, and it will come down like that, and down like that. I'll just darken it. And here, oh, I forgot to draw this asymptote. And this will go up. There we go. The green is a graph of the secant function. We'll pause. Let's try the cosecant function. Right, the cosecant function is 1 over the sine function. It's the reciprocal of the sine function, right? And so, again, we have problem areas when the sine is equal to 0. So the first thing I'm going to do is go in and draw my asymptotes. This one's hard to see. Okay. Can you see that? Probably not. This marker is dying. So I'll trade it out. Okay. 1 over the sine function. And very much like 1 over the cosine function, it will go through the points, the -1, the 1, and the -1 here. And here the sine function is all negative, and so the cosecant function will be negative. And here the sine function is positive, and so the cosecant will also be positive. And we'll do that down here as well. So it is periodic. The asymptotes occur at -pi, 0, positive pi, 2 pi, 3 pi, etc. So plus or minus pi's. And they aren't zeros, right? But they are like the maximums or the minimums of the u's here occur at -pi/2, pi/2, and 3 pi/2. And so this is a graph of the cosecant function and how we get it. If we were sketching the original function by hand, this is what I would have shown you on the whiteboard at school. I would also show you your graphing calculator. And I have a different calculator because I left the Casio calculators at school. I might go pick one up shortly, just so that I can show you guys things. But if you go to your graph menu and you wanted to graph sine of x, and 1 over the sine of x is how you would graph the cosecant on your graphing calculator. You want to make sure that you are in radian mode, and then when you graph, it will produce something like that. So you can see the sine function and the cosecant function on the graphing calculator. Okay, I hope that this helps you in your understanding of how to graph secant and cosecant functions, and I hope that you are all well. We'll see you next time.